Combination circuit, question 3. In this circuit we have a 90-volt battery which would produce a current that would run through this way and then split into two paths along this parallel circuit section. One resistor is 10 ohms, the other is 20 ohms. More current would pass through the smaller resistor, meaning there's more current passing through here. The current would come back together at this point, pass through the ammeter, through this resistor, which would add to the total resistance, and then once again split into these two pathways. Again, this resistor is smaller than this one, allowing more current to flow this way than through the 20 ohm resistor. The current would recombine at this location, and we can see that the reading is 4.5 amps, and then return to the battery. Because this is 4.5 amps, we know that the total of the current in this circuit has to be 4.5 amps. That would also mean that this current here, where the current recombines after the first break-off into the parallel circuit, would also be 4.5 amps. Therefore, R3 would be 4.5 amps. Now, what we need to do is find the total resistance of this circuit to help us find this here. In order to do that, we can simply take the total voltage divided by the total current, because we know the voltage total would also be that 90-volt battery. So the resistance total is equal to the voltage total divided by the current total. And so if we do the math here, 90 divided by 4.5, the total resistance is equal to 20 ohms. Now, to find R3, we need to figure out what the resistance is in these parallel circuits here. So these parallel circuits, and they're both going to be the same, and we've got two of them, we can find by going, so I'm going to call that the RP, so 1 over the RP is 1 over R1 plus 1 over R2. That's going to be the same on the other side. So let's do that calculation. So RP, 1 over RP, is equal to 1 over 10 plus 1 over 20. Using our calculator, we find that that value is 6.67 ohms. That means this one is also 6.67 ohms. So to find the total resistance in our circuit, we have to add these up. So RT, which we know, is equal to, I'm going to call this RP1 plus R3 plus RP2. Okay, those two are the same. So if we add these up, we had 20 ohms as resistance, plus RP1, which we just said was 6.67, plus R3, which is our unknown, plus another 6.67. If we do our calculation to find R3, we find that the value is also 6.67 amps. Or sorry, ohms. Alright. The next part here is finding the current at I2 and I4. Now, it seems like there's two questions here, but if you notice that I4 and I2 both have the current running through the 20 ohm resistor. So I'm simply going to calculate what the resistance or what the flow is through here. Now we know that in total we have 4.5 amps that's being split. The 4.5 amps, majority of it will go through here, the minority through here. So there's 30 ohms in total, and then this would actually allow more to go through than this one. So if I just simply take that ratio, so the which current was going through there, the 4.5 amps, and I multiply it by the ratio of, looking for the minority to go through here, so 10 out of 30, we can find the current there. So we find that 1.5 amps would be flowing through here. Now, the difference there, the 3 amps, would be flowing through the lower resistor. As mentioned, this is the same resistance as this one here with the same sort of setup. So the current through I4 and I2 would be the same. So this would be 1.5 amps as well.